We're going to go ahead and do lesson 4.7. We introduced an advanced mathematics concept called logarithms, or short, we say log. The definition's a little bit abstract and it's not easy to understand, but the idea is that a log, even though it's a word, it really is a math function. So for example, when you're young, you learn this symbol here means something. So when you get taught what does that mean, this is a square root, you know it means what times what equals 16, and it's 4. But it takes time to learn this crazy symbol because it looks like a division. Now, we're going to learn the log symbol, and you can see here the log of base b of some number, right? In order to answer that question, this question here, square root of 16, is really saying what multiplied with itself equals 16, right? That's the equivalent. Those are equivalent statements. And so we know the answer is 4 for that. So in this case, a log is related to an exponential function. And so again, it's hard to understand what this is until we look at some examples here. So for example, log base 3 of 81 equals 4. Why is that? Well, if we go ahead and let me cover this up real quick. If we go ahead and let's say we cover that up, you don't see it. Log base 3 of 81 is really asking you a question. 3 excuse me, raised to what number equals 81? We find out that that is 4. And so that's why this answer here, log base 3 of 81 equals 4. You can see this is the output from Desmos, how you would type that in there. Log base 3 of 81 equals 4. And so because it's really asking you an exponential function question. Here, 5 raised to negative 2, or 5 raised to, what's really going on here, let me cover this up. Let's pretend we don't see the answer there. And we say 5 raised to some number equals 0.04. And so in this case, that answer is negative 2. And you'd want to go ahead and check that on a calculator. Going back to negative exponents, what are they here? And so you can see, in order to answer that question, log base 5 of 0.04, again, is really asking 5 raised to what equals 0.04? It's negative 2. I want to show you what that looks like on Desmos. So going to Desmos here, excuse all the math there, but if we look at Desmos here and you say, we said log base 5, so we want to do a 5 there, of 0.04, you can see the answer is a negative 2 right there. You get a negative 2. Again, and that's because 5 raised to the negative 2 is equal to 0.04. So there's a relationship between that. And so you have that answer there. So what is the question being asked here? 2 to the power 5 equals 32. These are equivalent statements here. When we look at that here, those were equivalent statements. 2 to the power 5 equals 32. Log base 2 of 32 equals 5. Again, in here, these are equivalent statements. That goes back to our definition. Log base b of n is equal to this over here. Oh, right here. This is what we're looking at. So a log and exponential have a relationship. And so you have those there. Let's take a look at a few more without a calculator here, so you can see the answers here. 4 raised to what number equals 64? That's what this question is asking. This is asking that. That number turns out to be 3. And so log base 4 of 64 equals 3. Why is that? It's because that's true also. 4 to the power 3 is 64. That's the question that's being asked there. So if we wanted to do one more, let's say I invented another question. I say log base 4 of, let's say, 16. That answer would be 2, because 4 raised to the power of 2 equals 16. That's the question that's being asked there. Here are some more. Again, you could check with your calculator. You can see how we get some of these answers here. Log base 10 of this number means 10 raised to what is this? And that's a negative 8. So you can see how the answer gets written. Here, 36 raised to what number equals 6? It turns out to be 1/2. Log base 36 of 6 equals 1/2. Again, you can use Desmos to type that in there. Just make sure you understand that definition. Here is using your calculator here. And then looking at these last ones here, explain why log is of 3,500 is between 3 and 4. Now, what we're looking at is sometimes you have this 10 here. Sometimes if you don't see a number, it really means 10. Log base 10. So you don't have to write it. If you don't see a number, it's really your 10 right here. So just keep that in mind there. And so you can see log of 65,000 is this number here, because 10 raised to the power of 4.8129 is going to be very close to 65,000. So we have that there. Okay. And then why is this between, why do I see the answer? Why is this answer log of 3,500 between 3 and 4? Again, looking at Desmos, we can type that in, log of 3,500. You can see it's an answer between 3 and 4. I want to show you also, again, it's the same if you did a base 10 of 3,500 equals 3.54. They're the same. So if you don't see it, it means a 10 there. And so why is it in between? Because 10 to the power of 3 is 1,000, 10 to the power of 4 is 10,000, and 3,500 is in between. So your exponent has to be between 3 and 4. And then looking at the last one, is log base 3 of 2817 equal to 7? The answer is no, because 3 to the power of 7 equals 2187. So this is not correct.